Alrighty. Hi all. Thanks for watching today. We're going to be talking to you about rare and complex disease detection and how we can use AI technologies to assist in that. Before we jump into our solution to this issue, I want to first just give you a broad overview of what we consider to be rare and complex diseases and what the problem is. So rare diseases, as you might expect, would be diseases that are affecting a small percentage of the global population. And while that is true, each individual rare disease might affect only a small percentage of the population. Because there are so many rare diseases in general are actually a pretty big problem. They can affect 4% or more of the population. And when we add in complex diseases, which we would consider to be diseases that have multiple chronic conditions overlapping that make them very difficult to diagnose, that number can jump up to 20 to 30% of the global population. So we can see there are a lot of folks today living with these diseases. And we see the typical time from onset to diagnosis for these type of diseases to be 5 to 7 years. It's a pretty long time. It represents a lot of patient hardship during that time period where they're grappling with symptoms and grappling with their disease, but not knowing what the actual diagnosis is. It can be a strain on the patient, strain on clinicians, strain on the healthcare system in general. And when we talk about our solution today, we're really talking about this time from onset to diagnosis. We really want to shorten this time from 5 to 7 years to maybe even months or weeks, depending on how well this problem can be solved. Moving on from that, before we talk about the solution we're proposing, let's talk about why this can be a difficult problem to solve. First off, there's a lot of symptom overlap between these diseases and other more common diseases. So when you're looking at maybe one rare disease versus another, they share a lot of symptoms typically, same with complex diseases, and same with more common diseases as well, which can cause misdiagnosis and some of this issue of 5 to 7 years to get your accurate diagnosis. Also, in order to solve these, or in order to diagnose rather these diseases, clinician knowledge would have to be encyclopedic to just know all the different systems and all the interplay between all of these different rare and complex diseases to get you an accurate diagnosis. And that's not a knock on clinicians. It's just a really tough problem to solve and it requires a lot of knowledge there. We also are very familiar with the idea of siloed data access. In order to make these diagnoses, you need to have access to accurate data and quite a bit of it. So if we don't have accurate, or we don't have access to all of the different data silos, then we can't really make that accurate diagnosis. And then finally, when we're talking about AI, it's important to talk about the specialization of the AI. While AI can generally be very useful, if we're lacking AI specialization in this particular area, that can also be a hurdle to appropriate diagnosis. So now we've talked about that, let's talk more about our solution. We're going to demo it for you in just a moment, but before we do so, let me talk about, generally speaking, what is the flow of our solution. We envision a solution where a clinician could query an application, and then context could be extracted from the local patient record in, say, an IRIS instance, where that data can then be combined with additional patient data that we receive from InterSystems Health Gateway, which has access to a large number of health networks and pulls in a lot of that siloed data I was talking about just a moment ago. The relevant data can then be extracted and then via FHIR sent to an LLM, which can then recognize disease patterns and then surface possible diagnoses. Those diagnoses can be sent back to the clinician.
Oh my God.
Okay. There we go. Yeah, the diagnosis can be sent back to the clinician for analysis, and this would be sort of a human in the loop style solution in the sense that we're not just taking the recommendation from the LLM wholesale, but this is just one data point that the clinician could use to then make their diagnosis. And then just to call out the architecture for this, basically this is the same workflow I was just talking about. The user would submit their query to the application, which would pull context from IRIS and also Health Gateway. That context could be sent to the LM via FHIR, which could then surface an appropriate diagnosis, send it back to the user, who could then consider that as they make their eventual diagnosis for the patient. All righty. All that said, let me kick it over to Annie, who will then show you a demo of this in action.
Great. So I'm going to be doing the demo from the perspective of a physician. So from the physician's perspective, the hardest patients in actual practice are not the ones with very dramatic findings. It's typically the ones who keep coming back year after year with real problems that never quite add up. So that could be fatigue, that could be abnormal labs, that could be all kinds of vague symptoms. So each issue or each symptom is common on its own and is often managed by different clinicians at different times. So the challenge isn't data or isn't lack of data or lack of expertise. It's really that no one has ever been able to hold the full story at once. So I would start the way I would start clinically, where I would select the patient first. So we can see Alex is a 37-year-old male who's been flagged simply because he's had unresolved issues over several years without a clear unifying explanation. And before I jump into the analysis, I want to know what information might exist out of my local system. So it's a single action. I have triggered a request through InterSystems Health Gateway. So from my perspective, this is just one click, but under the hood, we can see there's an ADT style message that's being sent out with the patient's demographic information. So different national networks can locate records for this specific individual. And then Health Gateway reaches out to the different national health information networks, things like Carequality, CommonWell, eHealth Exchange, and retrieves clinical data from organizations where this patient has received care elsewhere. So for this demo, I'm simulating a FHIR load as if it's coming from Health Gateway and landing in the Iris for Health FHIR repository. So the structure and semantics exactly what I'd expect in production. So from a physician's perspective, this is going to look and feel exactly like a normal patient chart, just a more complete one. So I want to kick off the analysis before we take a look at the chart because it takes a moment to run. So we can see that nothing looks exotic on a first glance. It looks pretty normal. We see some chronic anemia. We see splenomegaly. And if I move over to the lab section, we can also see persistently low platelets. So each of these findings is pretty common on its own. What's different is that I'm seeing a broader history, including care that happened outside of my own health system. So for the clarity of the demo, I can always surface some information that clinicians wouldn't normally see or think about day to day. So you notice that each lab or observation is tagged with this source network, so I can immediately see where it came from, whether it's from Carequality, CommonWell, eHealth Exchange. But in everyday normal clinical use, I wouldn't need to see raw FHIR or network details. But I just want to make it very clear where the data is coming from and why the patient record is more complete. So now at this point, as a clinician, I'm not looking for an answer. I'm looking for perspective. So I've asked the system to look across this full cross-organizational record and tell me whether there are rare conditions or complex diseases I should at least be considering. So the analysis completes, and now I get a concise clinical summary followed by a short list of different conditions, possible rare disease considerations, with reasonings that also tie directly back to the patient's longitudinal history. So we can see the LM thinks that it's most likely to be Gaucher disease, which is a rare inherited condition where fat slowly builds up in your body. And this is causing years of fatigue, anemia, organ enlargement. And it's often missed because each symptom looks common on its own and no one ever sees the full picture at once. So seeing this explanation alongside with the record that includes outside data from multiple national networks immediately makes sense. But what matters the most to me is what the system doesn't do. It doesn't tell me that this is a diagnosis. It shows me why this condition might be worth considering and what evidence supports this reasoning. It also gives me some follow-up tests I might think about. So this mirrors how clinicians already practice medicine. It just gives us a fuller picture to reason from. And this is a value from a physician's perspective where AI does not replace judgment. It just helps physicians see the patients that they didn't know they were missing, and AI becomes a responsible second opinion.
Amazing. Thank you, Annie. So now that, oops. Awesome. So now that Jesse has articulated the problem and Annie has showed us a nice demonstration of a solution, I want to talk about why we think InterSystems is so well positioned to actually be the one to solve this problem. And the main reason we believe that is because of our next generation data platform, which underpins all of our technology and provides two critical capabilities: data management and interconnectivity. So we already have this product called InterSystems Health Gateway, and I'll talk a little bit more about that in the next slide. But the main point is that InterSystems Health Gateway facilitates the information sharing that is really needed to solve this problem. So we provide connectivity built in, we have native support for all popular data standards out of the box, and our data platform is multi-model. So that means we can unify structured and unstructured data of all different formats from all different kinds of systems. And we already have proprietary logic in our technology to deduplicate, normalize, and aggregate this data for a clean longitudinal record for each patient. So all of these capabilities together enable that real-time flagging and interaction with patient data, which is really important to flag a potential complex or rare disease risk. And finally here, InterSystems technology is trusted in several national health systems, processing millions of data points daily in very critical healthcare environments. So we believe that InterSystems is already in these systems, it's already working at huge scale, so why not add this problem onto the set of problems that we can solve? So like I said, I do want to take a second here to give us a little bit more background on the InterSystems Health Gateway solution. So the idea here is to give our customers one single connection to national health information networks like CommonWell, Carequality, and eHealth Exchange. And these networks that we provide access to actually cover more than 75% of US hospitals. So it's a huge bulk of the data that exists in the US. And our approach to this is based on a fully managed cloud service. We set up a single API connection to your health system, and we connect that to the national networks and automate the query and retrieval of available data for your patient. So it's a really easy setup that we handle, and then you get that information that covers over 75% of US facilities. Awesome. So now that you hopefully believe that InterSystems would indeed do a great job solving this problem, the question remains, what's the market for this? Would it actually be a useful tool for a lot of people? And the answer is a resounding yes. Because this problem affects a huge population and it's a population that's massively underserved, we believe that this problem is really worth solving. And as Jesse was saying earlier, even though each individual population of a singular rare and complex disease might be small, the amalgamation of all of these people who are experiencing these rare and complex diseases is actually a huge portion of our world. In addition, providers and health plans are more financially incentivized than ever to do things like meet metrics, provide positive patient experience, provide evidence that they are, using their resources so that they can get reimbursed. So being able to administer fewer tests, reach diagnoses earlier is really a key benefit for everybody involved in the healthcare setting. And we think that this type of solution could also help to alter the direction of life-changing medicines and treatments by enriching data and surfacing those diagnoses early again. And finally, the reason that we believe there's a big market opportunity here is because, yes, there are existing interoperability solutions, but they really have limits. So classic interoperability solutions might be really good at connectivity, but they still struggle with clinical context, surfacing the important data in real time, and they don't have that same single API approach that covers over 75% of US hospitals the way that InterSystems does. So as we get to the end here, I just want to wrap up with how we envision this type of solution affecting the healthcare experience in the future. So first, we see patient diagnosis times get cut from years to months or even weeks. We see that those diagnoses being more accurate. We see clinicians being supported by the AI, not replaced by the AI, but helping to decrease information fatigue, allowing them to better support their patients. And this is the type of solution that we also see just kind of generally helping health systems become more agile and proactive. Of course, at InterSystems, we're all about interacting with the data effectively and in real time. So the more that we can do that, we know the better experience everybody within the health system will have. And again, we see a big potential here for accelerated R&D in life sciences area, because with heightened awareness of rare diseases, more accurate diagnosis data, that population health data can be used to steer drug research, treatment research, and eventually save lives. Thank you very much for taking the time to watch our presentation and demo today. We really appreciate it, and we would be happy to take any follow-up questions you have.